Hello there, and welcome, where curiosity takes the gentle shape of a bedtime story, and science moves at the pace of a quiet breath. Tonight, we'll be wandering into the grandest question of scale that humans can ask. How big is the universe compared to the galaxy we call home? It's a question with a size built into it. And yet, no matter how many numbers or measurements are offered, it always seems to leave the imagination overflowing. We live inside something unimaginably large, but we also peer outward into something even larger. And tonight, I'd like to walk slowly through that difference with you. Before we set off, I'd love for you to consider where in the world you are listening from this evening. Perhaps you're in a city where the stars are hidden by a luminous haze, or perhaps somewhere rural, where the Milky Way itself can be seen stretching across the sky, a faint, ethereal river of light. Maybe it's late at night and you've tucked yourself into bed. Or maybe it's a lazy afternoon and you're simply looking for a calm pause. Either way, you and I are sharing this moment, and that's a small wonder in itself. If you find this kind of gentle exploration soothing or useful, I'd be grateful if you tapped the like button or subscribed, so others who might need a quiet voice to drift along with can find it too. Now, take a breath, settle into your chair or your pillow, and let's begin to think about what it means to be small in a universe that refuses to be anything other than vast. It helps to picture yourself outside for a moment. Imagine the night is clear and cool, the air still, and above you, the sky is open, scattered with stars. Maybe you can see just a handful because of streetlights, or maybe you see thousands. Each one is a point of light from another sun, many of them with planets circling, and all of them belonging to something bigger. When you look upward, you're not just seeing stars scattered randomly. You're seeing part of a vast structure, a spiral galaxy, the Milky Way, that holds those stars together in a loose but definite pattern. It stretches so wide across space that even traveling at the speed of light, you'd need tens of thousands of years to cross it. And yet, for all of its immensity, our galaxy is just one among billions, perhaps trillions, inside the universe. It's easy to speak in those numbers, but what does it actually feel like to compare them? Tonight, we'll try to take that measure step by step, always remembering that while the words sound huge, they are still just signposts pointing towards something our minds can only barely begin to picture. When you stand beneath the stars, it can be tempting to think of yourself as tiny, as though the great cosmos is stretching endlessly in every direction, and you're just a dot upon a dot, fading into the background. But there's another way of looking at it. You are part of the galaxy. You are part of the universe. The same atoms that formed inside stars billions of years ago are here right now in your body. The space above you is not separate from you. It is continuous with where you are sitting. The floor beneath your feet, the air in your lungs, the warmth of your skin, all of it is connected to the same universe we're about to measure. So instead of feeling small, you might also feel included, woven into the scale of what we're describing. As you let that thought settle, consider how unusual it is that we can even ask a question like this. For most of human history, the universe was the dome of the sky, and the galaxy was not even known to exist as a structure. People looked up and saw stars, sometimes a band of light across the heavens. But the idea that all of those stars were bound together in one great disk, and that the disk itself was only a piece of something far greater, that's a very recent realization. A century ago, astronomers were still debating whether other galaxies even existed. or whether everything we could see was contained within the Milky Way. Now we know that the Milky Way is just one island among countless others in a cosmic ocean. In that short time, our sense of size has expanded by a factor that is hard to put into words. That expansion of awareness is what we'll explore together. Think for a moment about distance in your daily life. A few steps to the kitchen, a walk around the block, a drive to another city, a flight across an ocean. Each of those scales feels tangible. You know what an hour in a car feels like. You know what a long-haul flight feels like. But when we begin to compare galaxies and universes, the scales grow so far beyond human experience that words like mile or kilometer become almost meaningless. Instead, astronomers reach for light years, the distance light travels in 1 year. Light, the fastest thing we know of, covering nearly 10 trillion kilometers in 12 months, and even then, that measure struggles to keep up with what we're describing. Our galaxy is about 100,000 light-years across. Already, that is a number that resists visualization. But compared to the universe, which stretches more than 90 billion light-years across in observable terms, it is just a single step on a staircase that seems to go on forever. This is where the imagination comes in. Tonight, we'll take it slowly, letting each number breathe, letting each comparison unfold without rushing, so that instead of becoming lost in a blur of statistics, you can build a kind of mental landscape. You can place yourself within the galaxy, see how wide it is, then compare it to the clusters of galaxies around us, and finally, to the observable universe. By the end, you won't have a perfect picture. That's impossible. But you will have a sense, a gentle awareness of the relationship between our home and the wider cosmos. That's all that's needed for now, because even a hint of that scale is enough to leave the mind both humbled and soothed. Take another slow breath, and let's stay with that image of being under the stars. Notice how they twinkle, how some are brighter than others. What you're seeing is just a small fraction of what's really there. In fact, from most places on Earth, only about a few thousand stars are visible to the naked eye. But our galaxy contains hundreds of billions of stars, most of them hidden from our eyes. Imagine multiplying the night sky you see by a factor of 100 million. That is closer to what the Milky Way actually holds. And then imagine that this entire collection of stars, gas, dust, and dark matter is just one galaxy among countless others. It is the difference between a grain of sand and a beach, between a single page and an entire library. The numbers become so large that they can almost feel comical. But here we are, sitting comfortably, asking the question, letting our thoughts drift across those scales without needing to solve them, only to feel them. It's worth pausing here to reflect on why this question is even soothing at all. Usually, when faced with something impossibly large, the instinct is to feel overwhelmed. But in this case, the opposite often happens. Thinking about the galaxy and the universe can be strangely calming because it puts daily concerns into perspective. The stress of a small task, the worry of a single moment, seems to shrink against the backdrop of billions of stars and trillions of galaxies. It doesn't mean those concerns don't matter. They do, deeply. But they are set inside a larger frame, and that can create a sense of balance. You are not the center of everything, but you are part of something that includes everything. In a way, it's a reminder that there is space for you, literally and figuratively, in the grand structure of existence. Now, let your mind wander back to the Earth beneath you. This planet is our starting point, and from here, we'll lift off in our imagination, first into the galaxy, and then beyond. Earth itself is about 12,700 kilometers across. That's a number we can picture more easily. A few hours in a plane and you've crossed a continent. A day in orbit and you've circled the planet. But scale it up to the solar system, with Neptune orbiting nearly 5 billion kilometers away, and already Earth feels small. Then place that solar system inside the Milky Way, stretched over 100,000 light years, and the solar system itself becomes a dot too small to notice. And then compare the Milky Way to the universe, which spans at least 90 billion light years across, and the galaxy becomes a dot in turn. This cascade of scales is what makes the comparison so remarkable. Each step is a world, and yet each step becomes tiny in the step above it. This is only the beginning. For now, though, we're still standing under that starry sky together, just beginning to ask how it all fits. The night is calm, the air is quiet, and the thought is simple. The galaxy is vast, but the universe is vaster still. When we think of the place we live, we often stop at the Earth, sometimes stretching a little further to the moon or the sun. Beyond that, things feel abstract, as though they belong to another category entirely. But the truth is that our real home, the place that shelters every star we see at night and every planet we've ever imagined, is the galaxy. The Milky Way is not a distant structure outside of us. It is the structure we're already inside. To talk about the galaxy is to talk about the stage on which every part of our solar system exists. Understanding it, even just a little, is like understanding the shape of the house you live in, rather than only describing a single room. Tonight, let's take our time to look around inside this home, to notice its features and scale, and to place ourselves within it in a way that feels grounded and calm. If you could step back far enough from Earth, away from the clutter of our atmosphere, and beyond the orbits of the planets, you would eventually see the Milky Way revealed. From within, on the surface of Earth, we only catch glimpses of its true shape. The hazy band of light that stretches across the night sky on clear, dark evenings is our edge-on view through the disk. But from outside, the Milky Way is a spiral galaxy, a flattened disk with sweeping arms curling outward, dotted with stars, nebulae, and clusters. At the center lies a dense bulge, a crowded sphere of stars orbiting a supermassive black hole known as Sagittarius A. The entire structure is laced with dust and gas, glowing faintly in wavelengths we cannot see with our eyes. To describe it in simple terms is easy. To imagine standing outside and looking back is harder. But even if we cannot truly picture it, we can place ourselves within its outline and begin to get a sense of our location. The disk of the Milky Way is about 100,000 light years across and roughly 1,000 light years thick. Inside this disk, stars orbit the center like a great whirlpool. Our solar system is located not in the crowded center, but out on one of the spiral arms, known as the Orion Arm, or Orion Spur, about 27,000 light years from the core. That distance alone is hard to absorb. Light, moving at the fastest possible speed, takes 27,000 years to travel from the center of the galaxy to us. That means when astronomers observe the central region, they are looking not at the present, but at light that left those stars long before human civilization began. We live in a galaxy that contains its own deep history. Simply by the way, light moves within it. It's worth pausing here to think about what it means to live inside such a disk. The night sky we see is not random. It is the view from one particular spot in the galactic neighborhood. When you look toward the thick band of the Milky Way, you are looking into the plane of the disk, where stars are crowded together. When you look away from it, the sky seems thinner because you're looking out of the disk and into the more sparsely populated halo of stars that surrounds it. Every direction you turn is still inside the galaxy, but the density changes with your line of sight. In a way, every stargazer is like someone standing in a forest. Look along the path of the trees, and the trunks seem close and endless. Look upward, and the gaps appear wider. The forest is the same, but your perspective changes. Our galaxy is like that, only the trees are suns, and the forest stretches for tens of thousands of light years. Inside this home, there are features as distinct as mountains or oceans on Earth. There are globular clusters, tight knots of hundreds of thousands of old stars that orbit the galaxy like satellites. There are vast nebulae, clouds of gas and dust where new stars are forming, illuminated from within by glowing hydrogen. There are supernova remnants, the husks of exploded stars scattered like cosmic fossils. And weaving through it all are the spiral arms themselves, regions where stars and gas are more densely packed, winding around the core in gentle arcs. Our solar system moves with the disk, circling the center once every 230 million years. That means in the time since the dinosaurs walked the Earth, our solar system has completed just one orbit of the galaxy. Each lap is unimaginably long on human timescales. Yet the galaxy itself has existed for more than 13 billion years, completing dozens of such rotations since its formation. We live in a place that is not only vast in space but ancient in time. The supermassive black hole at the center, Sagittarius A, deserves special mention. It contains about 4 million times the mass of our Sun, compressed into a region no larger than the orbit of Mercury. It is invisible to the eye, but its influence shapes the orbits of stars in the core. For decades, astronomers tracked the motion of those stars and confirmed that only a black hole of immense mass could explain their speed. In 2022, the Event Horizon Telescope collaboration released the first image of the region around Sagittarius A, showing a glowing ring of hot gas circling a dark shadow. That shadow is the closest we could come to seeing the black hole itself. Knowing that such a monster sits at the center of our galaxy is both unsettling and awe-inspiring. But in a strange way, it also makes the galaxy feel more like a living system, with a beating heart hidden in its core. Around the disk and bulge lies another component, the halo. This is a roughly spherical region extending far beyond the visible disk, containing scattered stars and globular clusters. More importantly, it is thought to contain vast amounts of dark matter, an invisible form of mass that does not emit light but exerts gravity. Without dark matter, the stars in the outer disk would not orbit as they do. The galaxy would simply fly apart. Instead, this unseen matter provides the glue that holds the structure together. In this sense, the Milky Way is not just what we see, but also what we cannot see, a reminder that our picture of home is still incomplete. So far, we've been speaking in terms of light years and billions of stars. Let's slow down and anchor those numbers a little more. Our Sun is just one among perhaps 200 to 400 billion stars in the Milky Way. That range is large because it's difficult to count stars hidden by dust or faint with age, but even the lower number is staggering. 200 billion suns, each potentially with planets. If only a fraction of those stars have habitable worlds, the number of possible places for life in our galaxy alone is enormous. And yet, despite this abundance, the stars are spread so widely apart that the nearest to us, Proxima Centauri, is more than 4 light-years away. Even if our galaxy is full of life, the distances are so great that neighbors would be hard to meet. The Milky Way is both crowded and lonely at the same time. A city of lights with streets so wide that each household feels isolated. As you let that idea unfold, think again about standing under the night sky. When you see the hazy band of the Milky Way, you're looking at the side of the disk, your gaze passing through thousands of light years of stars. That view is only possible from inside. From outside, you would see the entire disk stretched across space, tilted slightly, glowing faintly. Astronomers can't leave the galaxy to take that picture. But by studying other spiral galaxies, they infer what ours must look like. In a way, every photograph of another spiral galaxy is a mirror held up to us, showing what our home might look like if only we could step outside. Those images, taken with space telescopes, show elegant structures, arms lined with blue stars, dust lanes winding like smoke, and glowing regions of new birth. They are beautiful, but their greatest gift is that they let us imagine the shape of the place we live. This is not just idle wonder. Knowing the size and structure of the Milky Way is essential if we want to place it in the context of the universe. Only by measuring our home can we begin to compare it to the scale of the cosmos beyond. Astronomers have used a variety of methods to map the galaxy. They measure the motion of stars, trace the distribution of gas, and use radio telescopes to peer through dust. The Gaia mission, launched by the European Space Agency, has mapped the positions and motions of more than 1 billion stars, giving us a three-dimensional picture of the Milky Way with unprecedented detail. With each new observation, our image of home becomes sharper. But the vastness of it ensures that mysteries remain. Even now, the far edges of the disk and halo are only faintly understood. The more we know, the more remarkable it becomes that we are here at all. Our solar system orbits quietly in the Orion Arm, far enough from the center to avoid the dangers of dense star clusters, close enough to see the richness of the disk. It is a location that provides stability, sunlight, and a view of the night sky that inspires questions like the one we're asking tonight. To live inside a galaxy is not unusual. Every star belongs to one. But to be able to describe it in detail, to measure its size, and to compare it to the wider universe, that is a gift of both science and imagination. As the thought unfolds, notice how the scale of the galaxy begins to feel more comfortable. At first, 100,000 light years may sound overwhelming, but once you place the solar system within it, once you imagine the arms, the bulge, the halo, and the central black hole, it begins to take shape, like a map of a city. You know where you are in relation to the center. You know the direction of the arms. You know that the disk spins slowly, carrying everything with it. You know that the night sky is your local neighborhood seen from within. With that knowledge, you can begin to ask the larger question. If this is our galaxy, how much larger is the universe beyond it? But before we drift further outward, let's stay here a little longer, in the vast night of our galactic home, letting its shape and age sink in. The Milky Way is not just a background. It is the place in which we live every moment of our lives. Its gravity holds us. Its stars give us light. Its arms provide the structure of the sky. To appreciate its scale is to feel both humbled and sheltered. This is our home in the vast night. And knowing that makes the step outward into the universe even more meaningful. When we talk about the Milky Way, it is easy to slip into the habit of calling it our galaxy, without pausing to think about what that word really means. Galaxy. It is one of those terms that feels familiar, something you might first hear as a child when someone points at the sky and tells you that the stars all belong to the same vast collection. Yet, if someone were to stop you and ask directly, what exactly is a galaxy? The answer is not as simple as it seems. It is a word that covers something both straightforward and profound, something that can be defined by physics, but also understood only by stepping back to imagine what space itself looks like on the larger scales. Tonight, let's take our time to unpack that question. Not with the rush of a textbook definition, but with the slow, steady pace of a conversation where each layer is laid gently on top of the last, until by the end, the word galaxy feels clear, grounded, and less like a distant abstraction. The first place to begin is with the stars. A galaxy is, at its most visible, a collection of stars bound together by gravity. Hundreds of billions of them, in the case of the Milky Way. Fewer in the case of dwarf galaxies, more in the case of giants. These stars are not scattered randomly through space, but grouped into patterns, disks, and halos that hold together for billions of years. The glue that keeps them united is gravity, pulling each star toward every other, while their collective momentum keeps the system stable. Without gravity, stars would drift apart, scattered across the universe like sparks in the wind. But because of gravity, they remain bound, circling a common center, orbiting like planets around a sun, only on a far grander scale. But stars alone do not tell the whole story. The galaxy also contains gas and dust, the raw material from which new stars are born. These clouds are often spread thinly across vast regions, invisible to the naked eye, but glowing in radio and infrared light. Within them, under the right conditions, gravity can pull matter together, compressing it until nuclear fusion ignites and a new star shines. Galaxies, then, are not just collections of stars. They are factories where stars are continually created and destroyed, where the cycle of birth and death plays out across eons. A single galaxy can contain regions where stars are being born in clusters, glowing blue and hot, alongside regions where ancient stars are fading into dim red embers. It is a system that holds both youth and age, vigor and decline, all at once. There is another ingredient that makes galaxies what they are, one that is less visible but no less important. That ingredient is dark matter. When astronomers measure how galaxies rotate, they find something puzzling. The stars at the outer edges are moving faster than expected, as though held in place by an invisible hand. The only way to explain this is to propose that galaxies contain far more mass than what we can see. This unseen mass does not emit or absorb light, but it exerts gravity, shaping the motion of stars and gas. By every estimate, most of a galaxy's mass is dark matter. Without it, galaxies as we know them could not exist. So, when we say galaxy, we're talking about a structure made of stars, gas, dust, and also a vast, invisible halo of matter that outweighs everything we can see. Galaxies also contain central features, often supermassive black holes. These monsters, millions or billions of times the mass of the Sun, sit quietly at the cores of galaxies, their gravity influencing the orbits of stars nearby. Some are active, feeding on gas and dust, releasing jets of energy that shine across the universe. Others, like the one at the center of the Milky Way, are comparatively quiet, only occasionally flaring when a stray star or cloud wanders too close. The presence of these black holes suggests that galaxies and black holes grow together, each shaping the other over cosmic time. To define a galaxy without mentioning its core would be to leave out the heart of the system. So far, we have listed the pieces: stars, gas, dust, dark matter, and black holes. But a galaxy is more than just the sum of its parts. It is also about structure. Galaxies come in shapes that astronomers classify: spirals with graceful arms, ellipticals that are more rounded and smooth, and irregulars that have no clear form. The Milky Way is a barred spiral, meaning that at its center lies a bar-shaped structure of stars from which the spiral arms extend. These classifications help us describe galaxies, but in reality, each one is unique, shaped by its history of growth and collisions. Galaxies merge with one another, collide, and tear each other apart, only to settle into new forms. They are not static islands. They are evolving systems shaped by both their own internal dynamics and the larger environment of the universe around them. To better understand what a galaxy is, it helps to consider what it is not. A galaxy is not just a cluster of stars loosely drifting in the same area. It is not a temporary alignment of celestial bodies that happen to be close together. It is a gravitationally bound system, a family of stars and matter whose connections are strong enough to last billions of years. It is not just a visual pattern, like a constellation drawn in the sky from Earth's point of view. Those shapes are illusions, stars that only appear close but are actually separated by vast distances. A galaxy, in contrast, is a true physical structure, an island in the universe that holds itself together. Another way to define a galaxy is by scale. At the small end are dwarf galaxies, containing as few as a few 100 million stars. These are still immense by human standards, but tiny compared to giants. At the large end are galaxies with trillions of stars, stretching hundreds of thousands of light years across. In between are galaxies like our own, mid-sized spirals with a few 100 billion stars. Each type has its role. Dwarfs are often satellites of larger galaxies, orbiting them and sometimes merging into them. Giants dominate clusters, their gravity pulling in smaller companions. The range of size is vast, but the definition holds. A galaxy is a system large enough and cohesive enough to be self-sustaining over billions of years. The question of what exactly a galaxy is has not always been clear. A century ago, astronomers debated whether the spiral shapes seen through telescopes were nebulae inside the Milky Way or separate island universes beyond it. The answer came in the 1920s when Edwin Hubble measured the distances to these spirals and showed that they were far outside our galaxy, entire systems of their own. That realization expanded the scale of the universe dramatically. Suddenly, the Milky Way was no longer the universe, but just one among many galaxies. Since then, our understanding has only grown. With space telescopes, we now see billions of galaxies, each one a system in its own right. The word galaxy has become a basic unit of cosmic structure, as fundamental as the word star or planet. But on the grandest scale, when you hold that word in your mind now, let it feel less like jargon and more like a description of place. A galaxy is a home for stars, a cradle for new light, a container of history stretching back almost to the beginning of the universe. It is a balance of gravity and motion, of visible and invisible matter, of order and chaos. It is not simply something to look at through a telescope, but the actual environment in which every star we know resides. Even the universe itself, when described on large scales, is a collection of galaxies. In that sense, galaxies are the bricks of the cosmic wall, the units from which the universe is built. Think again about the Milky Way, not now as a unique object, but as one example of this definition. It is a barred spiral with hundreds of billions of stars, surrounded by a dark matter halo, containing gas, dust, and a supermassive black hole at its core. That description is enough to classify it as a galaxy, but then imagine Andromeda, our nearest large neighbor. It is another spiral, larger than the Milky Way, with its own black hole, its own arms, its own billions of stars. And imagine dwarf galaxies like the Magellanic Clouds, smaller companions orbiting us. All of them are galaxies too, because they fit the same pattern, bound systems of stars and matter, stable over cosmic time. If you were to look outward from our galaxy, you would see others scattered through space, sometimes alone, sometimes in groups. These groupings form clusters, which then form larger structures. But at the core of it all, the basic unit remains the galaxy. In this sense, to ask, what is a galaxy, is to ask, what is the fundamental building block of the visible universe? Without galaxies, there would still be stars, but they would not be organized into enduring systems. Without galaxies, the night sky would not show shapes and bands, but only random sparks. With galaxies, the universe takes on structure, patterns that can be mapped, measured, and understood. Now, let your thoughts drift back to that simple word, galaxy. It is easy to let it roll off the tongue without thinking. But inside, it is a richness that deserves time to unfold. It is a word that means home for billions of suns. It means cycles of creation and destruction. It means hidden halos of dark matter, unseen but essential. It means histories of collisions and merges, scars written in the orbits of stars. It means diversity of form, from spirals to ellipticals to irregulars. And it means scale, stretching across tens to hundreds of thousands of light years. To define it is not to shrink it, but to appreciate how much the word carries. In the quiet of this evening, with the stars still imagined overhead, you can let that definition settle. A galaxy is not something far away. It is the structure we live inside. To know what it is to know where we are. And once that foundation is in place, once the meaning of the word feels less like a mystery and more like a description, we can move outward again. When you think of the Milky Way, it is tempting to imagine the hazy band that stretches across the night sky, the faint milky glow that gave the galaxy its name. That view is beautiful, but it is also deceptive, because from our place within the disk, we cannot see the true outline of our galaxy. It is like trying to understand the shape of a forest while standing in the middle of it. The trees around you give a sense of density, but only from above could you see the full pattern of the woods. For centuries, astronomers had the same problem with the Milky Way. They could see the stars spread out in a broad plain, but only in the last century have we begun to understand the full shape and size of our galactic home. Tonight, we will let that picture unfold carefully so that the galaxy becomes less like a vague, glowing band and more like a map we can hold in our minds. The Milky Way is what astronomers call a barred spiral galaxy. This means it is shaped like a disk with long spiral arms curling outward from a central bar of stars. If you could rise above it, you would see a bright core, a thin, elongated structure of stars, and then sweeping arms that extend around it like ribbons. The whole disk is flat, about 100,000 light years across and only about 1,000 light years thick. In human terms, that thickness is almost nothing compared to the width, like a thin sheet of paper stretched to a size larger than we can imagine. This thinness is why the galaxy appears as a narrow band in our sky. From inside, looking across the disk, we see layer upon layer of stars packed together. While looking perpendicular to the disk, we see fewer stars and more empty space. At the very center of the Milky Way is the bulge, a rounded structure containing older stars, dense clouds of gas, and the supermassive black hole known as Sagittarius A. The bulge is not perfectly spherical, but slightly elongated, giving the appearance of a bar when viewed from certain angles. This bar is a defining feature of the Milky Way structure, extending for about 27,000 light-years across the core. From the ends of this bar, spiral arms emerge, winding outward with a graceful curve. These arms are not solid objects, but regions of higher density, where gas and stars are more concentrated. As stars orbit the galaxy, they move in and out of these arms, creating the impression of continuous structures, even though the stars themselves are always changing. Astronomers have identified several main spiral arms in the Milky Way, though mapping them precisely is challenging because of our position inside the disk. The major arms include the Perseus arm, the Scutum Centaurus arm, and the Sagittarius arm. Our solar system lies in a smaller branch known as the Orion arm, or Orion spur, between the Sagittarius and Perseus arms. This location is roughly halfway from the center to the outer edge of the disk, about 27,000 light-years from the galactic core. It is a relatively quiet neighborhood, not too crowded with stars, not too close to dangerous regions near the center, and not so far out that the density of matter is too low. In cosmic terms, it is a stable and fortunate address. The disk itself is not smooth, but layered with features. There is a thin disk containing most of the young stars and gas, and a thicker disk containing older stars with slightly different orbits. Surrounding both is the halo, a roughly spherical distribution of stars and dark matter that extends far beyond the visible disk. This halo contains ancient globular clusters, each a dense ball of hundreds of thousands of stars, orbiting the galaxy like satellites. The halo also contains most of the galaxy's dark matter, invisible but essential for holding the structure together. Without this hidden mass, the outer stars would drift away. Instead, they remain bound, orbiting faster than they otherwise should, proof that unseen matter outweighs the visible stars. The scale of all this is difficult to picture. A single light year is about 10 trillion kilometers. To cross the disk of the Milky Way at the speed of light would take 100,000 years. At the speed of our fastest spacecraft, it would take billions. This means that from one side of the galaxy to the other, stars are separated by distances so large that even imagining travel between them is daunting. Yet, within this disk are hundreds of billions of stars, most of them with planets, spread across the spiral arms like grains of sand on a beach. If you could look at the Milky Way from above, you would see these stars glowing in a faint disk, brighter toward the center, thinner toward the edges, threaded by dark lanes of dust that absorb light. The galaxy would look majestic, but also delicate, a luminous pinwheel suspended in darkness. The size of the Milky Way is not just a number, it is also a timekeeper. Our solar system orbits the center of the galaxy once every 230 million years. That means in the entire history of Earth, about 4.5 billion years, our planet has circled the galaxy roughly 20 times. Dinosaurs saw a completely different part of the galaxy than we do now. The continents drifted, life evolved, and the solar system moved quietly along its orbit, carrying us with it through the spiral arms. Each lap is so long that entire species rise and fall in the time it takes to complete one circuit. The size of the Milky Way is measured not just in distance, but in the ages it takes to move through it. The galaxy is also not static. Its shape and size have been influenced by interactions with other galaxies. The Milky Way is currently absorbing smaller dwarf galaxies, their stars stretched into streams that weave through the halo. In about 4 billion years, the Milky Way will collide with the Andromeda galaxy, its nearest large neighbor. That collision will reshape both galaxies, merging them into a new, larger elliptical galaxy over billions of years. For now, though, the Milky Way's shape remains that of a barred spiral, stable enough that we can describe it with confidence, but dynamic enough that change is inevitable in the distant future. One of the challenges of describing the shape of the Milky Way is that we cannot step outside it. Instead, astronomers use indirect methods. By mapping the positions and motions of stars, by observing the distribution of gas with radio telescopes, and by studying the light absorbed by dust, they build a picture of the disk. The Gaia spacecraft has been especially important, measuring the positions and velocities of more than 1 billion stars with incredible accuracy. With that data, scientists can trace the spiral arms, measure the thickness of the disk, and even detect ripples caused by past interactions. The result is a map that, while still incomplete, gives us the best view yet of our galaxy's true shape. The numbers describing the Milky Way's size are precise but also flexible, because the edges of a galaxy are not sharp. Unlike a planet with a clear surface, a galaxy fades gradually into the darkness of space. The stars become sparser, the gas thinner, until eventually, the distinction between the galaxy and intergalactic space is less obvious. Estimates of the Milky Way's size depend on whether you measure only the bright disk, which is about 100,000 light-years across, or include the dark matter halo, which may extend 300,000 light-years or more. In that sense, the Milky Way is larger than its visible stars suggest, its true size hidden in an invisible envelope. Thinking about this shape and size can feel overwhelming, but there is comfort in letting the details settle slowly. The Milky Way is not just an abstract object. It is the home that holds our sun, our Earth, and our history. Its spiral arms are the pathways along which stars are born. Its halo is the protective shell that holds it together. Its central bar and bulge are the anchor around which everything orbits. To know its shape is to know the architecture of our home. To know its size is to understand the scale of the stage on which all of human history and all of life on Earth has unfolded. Imagine once more that you're standing under the night sky, looking up at the hazy band of the Milky Way. Now, instead of seeing only a ribbon of light, imagine the full disk stretched out above you, 100,000 light-years wide, arms curling outward, stars scattered by the hundreds of billions. Imagine that your own sun is just one tiny point, circling slowly in the Orion Arm. Imagine that around you, unseen, is a halo of stars and dark matter extending 3 times farther than the disk itself. The night sky becomes not just a collection of lights, but the inside view of a vast spiral system. A home so large that it takes hundreds of millions of years to complete a single orbit. As you let that picture form, notice how the Milky Way becomes less abstract. It is not only a name or a glowing band, it is a structure with shape, size, and features that can be described. It is thin, flat, and wide, with arms that curl from a central bar. It is hundreds of thousands of light-years across, if you include the halo. It contains not just stars, but the unseen mass of dark matter. It is not static, but evolving, shaped by time, motion, and gravity. All of these details build a map, And though we may never step outside the galaxy to see it directly, our minds can hold that map, turning it gently until it feels familiar. Let's stay with this picture of home a little longer. A barred spiral, 100,000 light years across, with arms, a bulge, a halo, and a black hole containing hundreds of billions of stars. This is where we live. This is the shape and size of our galaxy. Now that we have settled into the shape and size of the Milky Way, it feels natural to lift our gaze a little further outward, as though we were stepping off the porch of our home to look at the neighborhood around us. A galaxy on its own is already immense, but it does not float through space in total isolation. It belongs to a community of galaxies, groups bound together by gravity, drifting and circling in patterns that play out over billions of years. When we begin to picture that neighborhood, the Milky Way becomes one member of a family, and the scale of our surroundings grows again. Tonight, let's take a slow walk through that cosmic neighborhood, placing the Milky Way in its local group, and then following the threads that connect galaxies into even larger structures. The most immediate neighbor to the Milky Way is the Andromeda galaxy. This is the nearest large spiral, larger than our own, about 2.5 million light-years away. That distance is staggering by human standards, but in cosmic terms, it makes Andromeda practically next door. If our galaxy is a house, Andromeda is the neighbor across a wide field, visible through the trees, but still close enough to notice. In fact, Andromeda is visible to the naked eye from Earth on clear, dark nights, appearing as a faint smudge in the sky. Through telescopes, it reveals itself as another barred spiral, filled with hundreds of billions of stars, with arms and dust lanes, much like the Milky Way. Knowing that such a vast system hangs quietly in our sky is one of the most grounding realizations astronomy can offer. The smudge you see is not just a patch of light, it is an entire galaxy, comparable in size and structure to our own, waiting across the void. Alongside Andromeda and the Milky Way are smaller companions. These are dwarf galaxies, less massive but still important parts of the neighborhood. The Large and Small Magellanic Clouds are two of the most famous, visible from the southern hemisphere as irregular patches of light. These dwarfs orbit the Milky Way, their stars and gas slowly being drawn in by our galaxy's gravity. Streams of material extend from them, evidence of the tug-of-war between small and large systems. The Milky Way has dozens of such companions, faint dwarfs that circle like satellites, many of them discovered only recently as astronomers developed better surveys. Andromeda has its own collection of dwarfs too, creating a pair of galactic families facing one another across the intergalactic gap. Together, the Milky Way, Andromeda, and their satellites form the local group. This is the official name for our cosmic neighborhood, a collection of more than 50 galaxies bound together by gravity. Most of them are dwarfs, faint and irregular, but the Milky Way and Andromeda dominate. Between them lies a balance of pull, a gravitational dance that will one day bring the two giants together. In about 4 billion years, the Milky Way and Andromeda will collide, merging into a single, larger galaxy. For now, though, they drift toward one another, closing the gap at about 100 kilometers per second, a speed that sounds fast, but will still take billions of years to complete. That slow inevitability is part of what makes the local group a true neighborhood. Its members are bound, not free to escape, moving together through space in patterns that can only be measured on cosmic timescales. The local group itself is not large by universal standards. It spans about 10 million light-years across, which is only a fraction of the observable universe. Within that volume, the galaxies are scattered, separated by millions of light years of empty space. If you could step outside and look back, the local group would appear as a loose cluster, with two bright spirals in the middle and a scattering of faint companions around them. It is not crowded like a city, but sparse like a rural landscape, with long stretches of darkness between glowing islands. This sparsity is part of the nature of galaxies. Even when they gather, the spaces between them remain vast, reminding us that emptiness is as much a part of the universe as light. Beyond the local group lies another layer of the neighborhood. The local group itself is part of a larger structure called the local sheet, a flattened region of galaxies that includes several nearby groups. Imagine the local group as one household and the local sheet as the street on which we live. Other groups, such as the M81 group and the Centaurus A group, line this street, each with their own bright galaxies and faint companions. Together, they form a pattern that is not random, but shaped by gravity, expansion, and the distribution of dark matter. The local sheet spans about 30 million light years, and within it, galaxies move slowly, relative to one another, creating a sense of stability over billions of years. One of the most prominent structures near us is the Virgo cluster. This cluster lies about 65 million light years away and contains more than 1,000 galaxies. It is the central hub of a much larger arrangement known as the Virgo supercluster, of which our local group is a tiny part. The Virgo cluster is a city compared to our small town, filled with galaxies packed closely together, interacting, colliding, and shaping one another. Some of the galaxies in Virgo are giant ellipticals containing trillions of stars. Others are spirals like ours, caught in the gravitational web of the cluster. The cluster itself is held together not just by the visible galaxies, but by an even greater mass of dark matter, a reminder that what we see is only part of the picture. As astronomers mapped these clusters and groups, they began to see patterns on even larger scales. Galaxies are not scattered randomly through the universe. They're arranged in filaments and walls, vast chains stretching across hundreds of millions of light years. Between them lie voids, enormous regions almost empty of galaxies. The result is a structure known as the cosmic web, a pattern of light and darkness that resembles a sponge or a network of veins. Our local group lies on one of these filaments, connected to larger structures that extend beyond what we can easily picture. In this web, galaxies are the bright nodes, groups are the intersections, and clusters are the hubs, all connected by invisible strands of dark matter and gas. This tour of our cosmic neighborhood is more than a list of names and distances. It is a way of placing ourselves within the hierarchy of the universe. At the smallest scale, we belong to the solar system, orbiting our star. At the next scale, we are part of the Milky Way, orbiting the galactic center. At the next, we are members of the local group, bound with Andromeda and dozens of dwarfs. Beyond that, we are part of the Virgo supercluster, which itself is just one piece of the larger Laniakea supercluster, a vast structure encompassing 100,000 galaxies. Each layer is both grounding and humbling, reminding us that our home is part of a system that grows larger and larger with every step outward. The word neighborhood can sometimes make the cosmos sound smaller than it is, but in truth, it is a useful way of thinking. Just as in a human neighborhood, some houses are close together while others are farther apart. Some are small, some are large, some are tidy, some are crowded. And like neighborhoods on Earth, these galactic communities are not isolated. They interact, influence one another, and evolve together. Our cosmic neighborhood is defined not only by what galaxies are nearby, but by the ways in which their gravity links them, pulling them into patterns that will play out long after our species is gone. Standing under the night sky, you can remind yourself that everything you see is inside one galaxy, the Milky Way. But beyond that faint band are neighbors invisible to your eyes, too far and faint to appear without telescopes. The Andromeda Galaxy, the Magellanic Clouds, the faint dwarfs of the local group. They're all out there, silent companions in the dark. And beyond them, clusters and superclusters, filaments and voids, stretching into patterns so large that the mind can only begin to grasp them. Yet in all of this, the word neighborhood still feels right. Because whether we are speaking of the house next door or the galaxy next door, the sense of belonging remains. We are not alone. We live in a community, one that is vast and ancient, but still a community all the same. As we finish this slow walk through our surroundings, the scale of the neighborhood becomes clearer. The Milky Way is our home. Andromeda is the great neighbor across the way. Dozens of dwarfs are like smaller houses clustered nearby. Together, they form the local group, which itself lies on the edge of larger clusters and filaments, part of a supercluster, part of a web. Each step outward adds distance, but it also adds connection. A galaxy is not an island. It is one node in a vast network. And as we continue outward, we will see that this network extends not just across our local patch, but across the entire observable universe, a neighborhood so large that it becomes the universe itself.